So welcome back to our Scala to Spark lectures or bootcamp, and now we actually finally get to do something a little bit more structured, right? So we'll be talking about structured API. This is chapter 4 in the book for those who have access to the book, right? And we will look at these basic building blocks, these basically this fundamental, like I said, they call it it's an abstraction. So again, so you think of these as tables basically, right? So again, so this will be more in-depth explanation, right? Some more some concepts, right? So let's get started. So I will start a new book, a new Scala example, right? Are we here? Yeah, we are here, right? So day 12, day 20. So object, day 20, and this will be we'll call it day 20 structured API overview, right? Something like that, overview. Okay, and add extends app, and again I think I had an example somewhere from a previous. Yeah, I'll do this one here, right? So again, stuff we all done before, right? And Spark session, we need Spark session, of course, right? And Scala version, right? On let's run it, right? So again, typical stuff, right? Or the Spark, right? Again, name is not that important, of course, of this application. Of course, that's up to you what kind of application you run. And we'll do a sanity check if it works. Looks okay. Now, so right. So again, just that's create that warning. Otherwise, looks fine. So we'll start with data frames, and this it's basically like tables, right? Again, that's an abstraction. Again, how it's stored internally. Again, quite a bit of magic there, but for all or us as users, developers, again, we can think of it as the table, right? So of course, columns shall have same rows, right? And of course, same number, right? But there it's possible to have null values as well, right? So schemas, of course, schema says what are the names, what are the type, right? So basically, Spark basically is actually, I mean, you just learn Scala, but Spark has its own language. Again, has its own has internal language. You could call it a domain-specific language. It's not a universal programming language like Scala, but it has an internal language basically, and then you access it through Scala, Java, Python, SQL, or R, right? Basically. So let's take a look at the so for example, this part here, right? It doesn't do it in Scala. It doesn't do it in Python, right? It actually does it in Spark, right? So let's take a look at this example, right? So. Right. Yeah. So this is basically an interesting moment, right? So here, right? So let's take a look, and you can see how it doesn't matter what kind of language we use. Of course, Scala is the first, but extremely. So select, right? So what's happening here? We selected the column plus 10. So the question is now, will we get any answers here? Can we do show here? Yeah, we can do show, right? Well, let's not do 500. That's too much, right? Let's do 40, right? Right. Okay, let's see. So basically, we create a range, so 0 to 39, right? We create has a single column number, and then we do this slight little bit of math, right? Just tiny little bit of math, and of course, so plus 10. So we got. Let's take a look. So starting from 10, and the column name is actually called number plus 10, actually, right? But the actual results are 10, and so on, right? We could do again if I did maybe let's do 5. Let's say I did 5, right? It would be, 0 to 4, right? And then we have 14, I mean 10, 11, 12, 13, 14. Let's do that, because again, a show cuts off by automatically right? Top 20, right? If you need more, you know, you can do 40, right? So again, I'll do again 40, maybe let's stick, but I'll show maybe 5, right? So you can see. Right. And obviously, right? And of course, naturally, if I put 100 here, right? You know, and put show 15, of course, I will show the first 15. So of course, this is the actual calculation. This is just for show, right? This is for show, right? You know, it's just for default for show is 220, right? So this is the actual Spark command. So here we have a Spark instruction, basic command. You know, to say select a column and add 100 to it, and we show it. So of course we didn't save. By the way, we could have we didn't save it, right? We did not save it in new data frame, right? We just show the results, right? So did we run it? Yeah, we're running it. Okay, so 100, of course, right? Started with 100, right? Because we started 0, right? And go to up 15. Okay, so that's basic idea. We already saw it a couple times, right? And well, technically, data frames, right? On basically, there are basically. So there are two types of access. We have been using both data frames and data sets, right? But we most likely use data frames because, well, basically in Scala, right, as I've been telling you, they are basically simply data sets of rows, right? So, so row is an internal representation, right, of this for computation, right? It's very efficient. Again, we can't really go inside what's happening there, right? So, any costs. So, other languages, it's not as so. For Scala, it's slightly more. You have slightly more. You can be more strict in Scala, unlike like in some other language like Python or R, right? Which are more loose, right? I work with some other languages as well, but Scala is strict, so it's slightly more safe, right? So Spark in Scala, right? Right. So. Right. So how about columns, right? So how about columns, right? Right. Simple type, integer, string, right? And Scala Spark tracks all of it, right? And which you can transform, right? So right. So columns, right? So. And maybe we'll have some examples, right? So rows is nothing more than record of data, right? So each record must be data frame because, of course, it is a data frame of these type rows, right? Again, underneath you have something called RDDs, but we don't really need to. So these both, right? We have a range to df and collect. Let's take a look at this collect. What the heck is collect, right? So row is nothing more than record data, right? Right. Right. So we have many ways of doing this, multiple ways of doing it, basically, right? So let's take a look at this, right? Right. So again, single column, right? So this collect, what the heck is collect, right? Returns an array that contains all the rows in this data set. So this range, right? So this will be result, right? Range array, right? I mean my tiny range, right? What it's gonna be array of rows, right? Which basically, well, it's not quite the same as the data frame, right? You have array, of course, is our basic unit which we've been operating before, right? So then we can so collect. So what's collect? So collect moved our data. the data into our own program memory, right? Because it is now an array, right? Which is one of our basic data structures in Scala, Java, etc. Right? So so that's collect. So if you need it localized, so if you want to move from calculations, work on something from the Spark jobs into Scala, right? Just pure Scala, right? You can use collect, right? So so this is tiny. So can we do? So we can do tiny. Well, let's do something bigger, right? So we'll do something bigger. So while our row will be Spark range, right? 10. Let's say something like this. To df, of course. We'll call it. Let's say what the column names will be. Column names will be. Let's see. A single one. I'll do maybe my numbers, right? And then, of course, we want to collect it, right? We want to collect, right? This is array of rows, right? Array of rows, of course, right? And let's see. So we can do now. So now we can use regular Scala stuff, right? Like slice, you know. You can take 3, for example, right? And for each print line, for example, let's try this. Print each row, right? Let's try this. Take first 3 or head 3, right? You know, head. Let's try this. Yeah, so 0, 1, 2, right? Prints, right? Again, we're printing. These are arrays of rows, right? Of course, we'll get the rows could have more than one column. Of course, here we only have here. So we have an array of rows with a single column each here, right? Okay, and we can do this regular stuff, right? Slice. We can do something like, let's say, 3 to 7, for example, again for each print line, right? Well, let's say 2. And let's do also tail, right? Let's do tail, right? Can we do tail? Row tail. Yeah, tail, I think. Right, tail. And can we do multiple? No. Yeah, can we do that? Let's try this. Tail, right, for each. Okay, and tail. It's a single one, right? I think it's array of no, wait. I think tail is just single one, right? Yeah, tail print line, right? Tail. What is that? So we can do print line. Yeah, like this, right? It's the last one, right? It's a single element, right? So 10. So there should be 9. Should be row holding 9 here, right? Okay. First 3 elements, right? So this would be 3rd to 7th element, right? 3rd, right? 3rd. Right? Index starts with 0. Starts. Okay, let's take a look if this works. And that should be actually enough for an exercise as well, right? Yes, they are. Only thing didn't work like this. So this tail, right? To string, I believe, maybe, right? Can we do this to string? Yeah, let's try this. Maybe to vector, perhaps. Vector of rows. Let's see. What is tail? Tail. So our row, array of rows. So tail is everything. Or was it last? Last. I meant last. Okay, last. Right. Yeah, last, not tail. Right. Last. of course last, right, first, right. So of course print line first. Head, of course, right. So these are just basic operations. Okay. Okay. Tails everything except the last, except the first element, I believe, right? So yeah. While it's running, let's check our time. Yeah, we still have a few more minutes we can work on. So numbers, so first is 0, last is 9. Okay, I mean nothing too crazy, right? We started with these are first 3 elements, and these are third 2 sevenths, right? Makes sense, right? Okay. Starting from 0, right? First 3 elements. First 3 elements. Okay. So far so good. Well, let's see, do we have anything else we want to check before? Right, we have different types, right? We can check, right? Alright, so we will need to work maybe with some types, right? And there's specific data types, right? And many different data types are supported by Scala, right? So byte, short, int, long type, right? We can actually import these here. So I'll show you, I won't import them, but again, if you need to. So this is the idea, right? And I will. Right, so this is what? A byte type, right? Basically, but this imports all Spark data types, right? Again, so there's a chart, right? Do we have a chart for Scala? This is for Python, but for Scala, yeah, this is the one we want, right? You probably just pay attention. I saw what's Scala, so it's byte type, long type, so pretty much big decimal type, array of bytes, binary type. So some different things. So sequence, right? So what's in Scala? So what's in Spark, basically, right? So row, right? And structure type, right, is in here. Sequence, map, right, map type. So that's so what happens underneath, right? So again, we have our code, right? We write code, of course, which we do, right? Then Spark converts this to a logical plan, right? So what's logical plan? What's physical plan, right? So logical plan is kind of like a higher level, right? Right. So and then you have a optimization, right? What to do, right? So it's like a it's basically abstract plan, like that. It does not go into technical details, so to say, right? The Spark engine, right? It says, okay, what needs to be done, right? But does not yet know how to do this physically, how it's going to be done, right? So there's again, that's what's happening underneath these data structures, right? These transformations, right? So there's a catalog of all the information, basically, and you have basically some optimizations, and then you come up with this logical plan, and of course then you move on to physical planning, right? And that's actually is how it's actually going to do, how it's actually going to, because remember, underneath you have multiple machines, right? How to do it best. It's kind of similar how, again, we don't usually worry how SQL does its magic when we're doing select statement, for example, right? There's a special engine, right, which does the work. So Spark also, of course, also similarly how some other database, right? We don't really go into how it's going to do the work, right? Here also, you generally don't need to go inside, see how Spark plans does this physical plan, but you can always inspect, right? So you have a logical plan, right? And it says, okay, what's the best way to do it again. So this is basically the big picture of what's happening underneath, right? So again, not something you need to worry about programming wise too much, right? But what's happening actually underneath this. So you have this logical plan, right? These what has to be done, and physical plan is actually how much, like different plans, and actually because, well, it could be, you know, maybe you have huge tables. Again, it tries to estimate, well, how long it will take, right? How much, what kind of transformations, right? So Spark itself, you could call the compiler, meaning you take in queries, right? You know, in SQL, there's sets, data frames, and you have these transformations, you know, to actually do the work. So this actually defines, okay, Spark figures out one of these plans will be the best, you know, will cost, you know, cost model, best meaning costs the least as far as, you know, computing resources, and then it's actually done, that runs for you. Of course, no plan is perfect, right? So again, it's this, maybe there's a better plan, right? But this is the good news for you, is you don't have to worry about it, because that's responsibility for those maintaining Spark engine to come up with a smart enough engine to scale, get the best plans for you, right? And you get the, as Spark develops, you gain the benefits of this, right? You don't have to worry, you just write the code, right? So that's basically the big plan, right? Of course, all the code runs, and again, in old days, like 10-12 years ago, you had to do this manually in the RDDs, and right, and nobody wants to do that. Again, it's very painful, right? It's technically, you can still do it, right? If you ever need to, but I would say it's highly unlikely you will need to do it, right? So because this works very quite well, right? These calculations, right? On so I think this is a good conclusion. We can move on to basic operations. We'll do that next, in probably after the break, right? Tonight. But so and we will look at the basic operations, right? So let's see, what I want to do for you, right? Let's see, can we do DataFrame, right? So you will have simple task, right, to do. Create a DataFrame with a single column called, you know, let's say July numbers, right? Numbers from, well, the question is from 1 to 31, right? Yeah, called July numbers, right? Called like this, right? From 1 to 31, right? Let's see, on print, right? On the questions, can you save it? Let's see, will you be able to, I would like to, maybe you could try saving it as a numbers on a CSV, but again, notice how since CSV, Spark can split the CSV into multiple parts, by the way, right, for large data sets. So that's something I don't want you to worry about too much right now. So let's just show, right? Show all 31 numbers, right? So show all 31 numbers, right? Right, and actually, right, and I want to be, right, so and maybe, right, create a new data frame with numbers from let's say 100 to 3100, right? Right. So again, just show last 5 numbers. Okay, right? I think you can do that, right? So that's a basic exercise for tonight. So another data frame, right? So that should be to do and to do. Simple stuff, right? Basic things. Well, thank you, and I will add this to commit. I'll commit this.